Welcome to Homework Lib.
Hi, so in this case we're going to have the solubility product of silver chloride as a solid that is going to turn into silver plus in aqueous media plus chlorine minus in aqueous media as well. And we want to find what is the molar solubility in a 0.05 molar solution of sodium chloride. Recall that sodium chloride is a salt, dissociates completely, so 0.05 molar of sodium chloride corresponds to 0.05 molar of Cl minus in my solution. And the other information that we have is that the solubility product is equal to 1.77 times 10 to the minus 10. So we're going to start with our ice table. We are going to use concentration since we're given the concentration of Cl minus in the solution. Remember that solids do not enter into the equilibrium constant. Initially we have 0 silver plus, but we're going to have 0.05 of chlorine minus. The amount of change that we're going to expect is the solubility, the molar solubility of the silver chloride, adding plus S and plus S over here. At equilibrium, the solid doesn't matter, but we're going to get S and 0.05 plus S. So now we can write down our solubility product constant that, just as a reminder, is the product of the concentration of silver plus times the concentration of Cl minus in this case. Replacing the values, this becomes S times 0.05 plus S. So over here we have two different options. First of course, this is going to be equal to 1.77 times 10 to the minus 10. So we could go ahead and solve the quadratic expression that looks like S squared plus 0.05 S minus 1.77 times 10 to the minus 10 should be equal to 0. So that is the first option. The other one is, well, we know that the solubility product is something in the order of 10 to the minus 10. We know then that the value for S is going to be quite small. So if we assume that 0.05 is much larger than the value for S, we know that 0.05 plus S is essentially going to be 0.05. That simplifies our equation, and the solubility product now becomes S times 0.05. Thus, to find S, the molar solubility, we simply need to divide 1.77 times 10 to the minus 10 divided by 0.05, giving us 3.54 times 10 to the minus 9. And this would be the molar solubility. As you can see, our assumption holds. Indeed, the value for S is much smaller than 0.05. And if you solve the full quadratic expression, you are going to find a very similar value. So that would be all. Thank you very much.